What if the universe doesn't end by expanding into infinity or collapsing into a final singularity, but by quietly returning to C? In the energy filament theory, the ending can look like a long retreat. The energy C keeps relaxing. The relay of influence grows weaker, and the responsive universe slowly narrows like a shoreline pulling back. To see why, go back to the engine. When stars ignite and galaxies weave into a web, it looks like growth, but it's also bookkeeping. More and more tension gets locked into stable hierarchies, atoms, dense objects, black holes, and the cosmic web scaffolding. The freely mixing, fast exchange part of the sea shrinks. The sea becomes harder to stir. You can picture it like soup left on the stove too long. The soup doesn't vanish. It thickens, settles, and forms stubborn clumps. The fluid part becomes less willing to flow. As the sea loosens, the first thing that weakens is the relay. Forces and information depend on the sea's ability to hand a disturbance from patch to patch. If the media gets too loose, the handoff becomes sluggish and then unreliable. The way sound fades in air that is too thin. So the cosmic boundary doesn't need someone to push a wall outward or pull it inward. It behaves more like a coastline. The outermost region becomes a forest desert first, then a transition belt where stable particles struggle to hold their patterns. And the zones that can support complex structures drift inward over time. We won't argue timescales here. The direction is the key. The window where stars can form and complex chemistry can persist becomes narrower. This also explains why a global collapse and reboot is not the default ending. To bring everything back into a single mother black hole, the whole sea would need to become globally tighter and globally organized into one deep valley again. But relaxation does the opposite. As relays weakens, it becomes harder for far regions to stay dynamically coordinated by one global story. The cosmos tends towards gradual decoupling, not total reconvergence. Imagine a shoreline at low tide. Water doesn't rush back into one perfect whirlpool. It spreads out, quiets down, and distant regions go calm first. So what would the late universe look like in this picture? Not a sudden blackout. More like fewer and fewer places can light up. The cosmic web becomes thinner and harder to resupply. Cluster growth slows. Star formation rates fall. Long-lived stars burn through fuel and fade. The habitable belt behaves like a climate band that slowly drifts and shrinks. Regions that can host stable complexity become rarer. Black holes continue acting like recycling stations, swallowing and rearranging. But they also slowly leak through their porous critical skins, fading rather than exploding, and smoothing the sea's background as they go. In the end, the universe becomes a vast but sluggish ocean. Big terrain differences are worn down. Long-range influence struggles to propagate. And what remains are local ripples and extremely slow relaxation. That's why the end here is neither running outward forever nor falling back in. It is a retreat back to sea. Boundaries recedes inward. The responsive windows narrows, and structures ebbs away like a tide. If the origin is an overflow from an extreme tight state, the ending is the long quiet after the overflow, when the media keeps relaxing. You don't have to treat this as a final verdict. Treat it as a testable end map. If the relay truly weakens with relaxation, there should be signatures of narrowing windows and fading structure growth that can be searched for in the sky. Next episode we talk about those signatures. If the universe is slowly going quiet, what should change first, and what should remain stubbornly unchanged? Tap follow, share it on New Physics, Clear Universe.